All right, hey gang. I'm just going to introduce a couple of things from this review that I think might be problematic, and then I'm going to let you roll. So hang on, and let's take a look here. Let's see here if I can go there, make it look a little nicer. Boom, that's good. All right, here's what I want to do in taking a look at number 5 down here. Basically, we have to figure out the measure of arc AB. Now remember, the measure of an arc is in degrees. Okay, in degrees. So we are looking for a certain degree here, okay? So as I look down here at number 5, I guess the thing that sticks out to me is if I can go ahead and figure out what x is going to be, this angle right here, I should be able to figure out what this degree is going to be for this arc right here. And if I can do that, then I can go ahead and double it to get the measure of arc AB. Okay, so that kind of gives you some background information on where we're heading on this. So what I'm going to do, going back to the original picture, if I can get rid of some of this here, what we notice here is that from A to B, that chord length was 30. Well, being that this is a right angle right here, I'm going to go ahead and break apart that 30 into a 15 and 15. So what we're basically looking at, I'm going to rotate this triangle just a little bit here so we can see a little bit better. That right triangle has a length of 15 here and a length of 17 here. And the question really is, how do I figure out that degree right there? Well, hopefully we haven't forgot about this, but if you think about it, here's the opposite side and here's the hypotenuse. So I can use my trig function of the sine, okay? So if I write this down, I can use the sine of x is equal to the opposite over the hypotenuse. That right there is going to allow me to get the measure of x. So if I go ahead and solve for x, remember when we're solving for an angle, we use the inverse trig function. And I'm not even going to do it right now because I know that this arc measure here will be equal to twice this much. So maybe I'll write it like this. The arc measure of AB is going to be twice the sine, inverse sine I should say, of 15 over 17. Okay? So when I plug that into my calculator, let's see what that's going to be. Raise this up a bit. Okay. Whoop. How about we do that? Clear that. So 2 times the inverse sine of 15 over 17. Ooh, let me try that again. I typed in 47. 15 over 17. All right. So if you can't see it there, it says 123.8. Okay, and I think it says nearest tens place at the very top. So I'll just put 0.9. So 123.9 degrees for the measure of arc A all the way over there to B. Okay? That's the first thing I wanted to cover. The second thing and the last thing I'm going to cover is number 7 here. Okay? Love these type of problems. They just get you thinking about a lot of different things. So there's different ways that we can go ahead and solve this type of problem. I guess the first thing I noticed when I just glanced at this was that we have this angle, but we don't have this one. Remember what the relationship was there. The opposite angles, when you have an inscribed quadrilateral, are supplementary. So 100 plus D will equal 180. So I know that D is equal to 80 degrees. And I'll put that down right there, 80 degrees. Okay? I can do the same thing with the 96, the fact that those are supplementary. So I'll do, there you go, 80 degrees. Okay? I can do 96 plus C is equal to 180. And if I subtract 96, we get 84. So that would be C degrees, 84 degrees. Okay? Now from there, how do we go about solving for A and B? Well, there's several ways we could look at this. I could extend the 100 out, and this 100, the inscribed arc is this whole arc right here. Okay? So if I know that this whole arc is 200 degrees, how do I find the measure of this arc right here? Okay? Well, that arc right there is going to be 200, doubling that, 200 degrees minus the 99 gives you A. So I may write it up here. A is equal to 200 minus 99, which is going to be 101 degrees. A is going to be 101 degrees right there, okay? If I wanted to find B, again, you can do it in several different ways. I can go ahead and, let's see here. Probably the easiest thing is to look at C, angle C, the inscribed angle at C. And we know that this arc right here, from here all the way over to here, has to be double the angle at C. So it has to be 168 degrees. Now, if A degrees is 101, then we're going to take 101 from 168, and that should be B degrees. So 67 degrees will be B degrees, okay? Now, you know, we could continue to double check ourselves if you wanted to. You could always go ahead and extend this angle out and say, hey, this whole arc right here has to be twice at 96. What would that be? 192, 180, yeah, 192. And if we take 192 minus 99, 93 degrees. Okay, now here's the question. Does this add up to 360 degrees? So I'll double check it here. If I add up 93 plus 101 plus 67 plus 99, 360 degrees. Boom. Okay. So I hope that makes sense. I hope you understood how I looked at these angles and the arcs opposite and was able to figure out the different parts of those problems there. So I want you to go ahead and figure out the other, not that one, sorry, the rest of those problems on the worksheet there, okay? Let me know if you have any questions. We'll talk about them. Good luck. We'll see you.